So this is a Liberty ship failures. This is a very famous photograph. The Liberty ships are the ship which was used in the World War in the Europe area. This is a figure 1.3. The Liberty ships in 1943 failed before leaving the shipyard. This ship was made and constructed. And then before fighting, before going into the war, this ship is failed like this. This case is illustrated one role that material scientists and engineers are called upon to assume in the area of the material performance. Analyze mechanical failure, determine their causes, and then propose appropriate material to guard against the future incidents. In this sentence, very important keywords are involved. For the material science engineering, understand the material performance, of course, and then if failure occurs, analyze why this failure occurs or not, and determine the cause. This is a basic cause of this failure, and then propose appropriate measures and appropriate new materials. So understand the material's performance, and if the failure occurs, analyzing that failure and to find out the source causes of that failure, and propose a new material, new system. That is a main role of the material science. This failure, the failure many of the World War II Liberty ships is a well-known and dramatic example of the brittle failure fracture of the steel that was thought to be the ductile. So normally, until this Liberty ship's failure, people understand that metal has a ductile property. Ductile property means very high elongation for the failure. But according to that photos, that ships fracture into two parts. That is not a ductile manner. That is a very, very brittle manner. Some of the early ships experiences structural damage when the crack develop in the decks and hulls. Three of them catastrophically split in the half when the crack formed, grew the critical length, and then rapidly propagate complete around the ships. And that figure showed one of the ships fractured in day after it was launched. When some normally ductile metal alloy are cooled to the relatively low temperatures, they become susceptible to brittle fracture. That is, they experience ductile to brittle transition upon the cooling through the critical range of the temperature. So that ship was made on the north of Europe European country. So therefore, these areas are not so hot, very cool temperature. In the case of the cool temperature, that metal alloy were used in these ships. Normally, normal room temperature, hot environment, so that this metal alloy shows the ductile elongation very high. But in the cool condition, that ductile properties change to the brittle. So that is the ductile to brittle transition. These Liberty ships were constructed of steel that experienced a ductile to brittle transition. Some of them were developed to the reached North Atlantic. Once ductile metal experienced brittle fracture, when temperature dropped to below the transition temperature. The corner, and then next is the design of the ships. Corner of each hatch is a door, was square. Square means square. The corner acted as a point of the stress concentration. So that at a very sharp corner becomes the source of the stress concentration, and from here, crack start. German U-boats were sinking cargo ships faster than they could be replaced using the existing construction technique. Consequently, it became necessary to evaluate construction method to build a cargo ship fast and in greater numbers. This was accomplished using the prefabricated steel sheets that were assembled by welding rather than by the traditional time-consuming rivet. So they changed the processing method. Processing means processing material, not material. Processing of the ship body. They use a welding method. When we compare the welding and riveting, so riveting is needs more time to make that ship structure. Welding is easy. So that they use a welding technique. And unfortunately, cracks in the welded structure may propagate and imprint to the large distance, which can lead to the catastrophic failure. So, however, when the structure riveted in the crack causes a propagate once it reaches the edge and steel sheet. So from the welding part, so if the welding is weld defect, it's discontinuous part. Welding defect means there is air inside of the welded part. So that is a initiation of the crack. So this is welding. Of course, this is an easy way, but by using a human hand, human feeling. So welding engineers, welding technicians needs more high ability, large long-term experience, and they are required high technique. So if I make a welding part, probably that welding part is completely not so good. So there's many errors, something wrong. So the weld defects are the discontinuities, and crack can be formed, and then that was propagated. So the major technique correct the problem. So the material science engineering try to understand why this ship has a catastrophic failure. So they analyze that failure, and they try to find out the source of that failure, and then that is welding part, and lowering the ductile brittle temperature of the steel and acceptable level by improving steel quality. So therefore, in the case of the lower temperature, so one of the way is to improving the steel quality. More high quality steel should be used. That is one of the answer from the material science engineer. And then regarding to the hatch, in order to avoid the stress concentration at the corner, so the rounding of the hatch corner should be used. And instead of the welding, it is better to use a rivet structure. So the rivet structure can stop the crack propagation. And also, if welding technique are used, so improving the welding practice and establishing the welding course. This is new improving the steel quality and rounding off the hatch corner, rivet, and improving the welding technique. These 4 issues were proposed from the material science and the engineer. And then the Liberty ship program was considered again, and they make a new ship. And then most important point is from the brittle fracture. So from this ship fracture mechanics, that is a new solid mechanics field was started. So that means when we studied about the strength of materials, when we apply the tensile load of the materials, so we assume materials are perfect, no defects, no void. So, but in the case of the void or some defect structure, that is same as the welding part of the Liberty ship. So from that incontinuity part, fracture initiate and propagate. So how to understand that initiation of the fracture and how to understand the propagation of that fracture? fracture mechanics, that new solid mechanics field are started. So therefore, for the material science and the engineers, not only material science engineers, but also the designer or applied scientists or mechanical engineers or more civil engineers. So the fracture mechanics is very important engineering field in the solid mechanics at the moment. So this Liberty ship failure make a new academic field, that is fracture mechanics. And the corners, windows, and door, so that is rounded. So when you get on the train window is not square. That the corner should be round. That is that meaning is avoiding the stress concentration at the corner for crack initiation.